It is very much my pleasure to introduce one of the most interesting women in the world, Dr. Barb Taylor. Well, I've never had an introduction quite like that. I'm going to have to start sniffing my blood some more, I guess. I was warned that it's always harder to talk at lunch than to talk at dinner, according to Bob Haskell, because you guys aren't liquored up. So I'd like to encourage all of you to have a mental read. And I'm actually... Whoa, there we go. I'm going to start out by reading to you from a journal that I wrote for my mother this last Thanksgiving Day while I was out at sea. In Hawaii, way out there in the middle of nowhere. The ship is noisy, the food is not up to cruise ship standards, and we're away from family on Thanksgiving Day. Why do we do it? The magic. Like sailors and explorers of our species for thousands of years, there's always more boredom than magic, but the moments of beauty outweigh the days of tedium. Yesterday, after an entire day of seeing absolutely nothing, the observers called excitedly over the radio, "We've got blue whales." Blue whales are the largest animals, it went out again, on planet Earth. There's never been a larger animal. We know very little about blue whales, and this is despite killing hundreds of thousands of them and nearly depriving future generations of such a magnificent creature. We don't even know how many species or subspecies there are, much less how they navigate through the vast three dimensions of the seas. But we do know that different groups have different songs. The Navy used to maintain deep-sea listening devices off the Hawaiian Islands to listen for enemy submarines. They inadvertently recorded blue whales. Yesterday was the first time these particular types of blue whales had ever been seen in Hawaii. Once before, I had seen these rare denizens of the Central and Western Pacific in the far western Aleutian Islands. It too was a day of magic, finding one of perhaps only a few hundred remaining individuals far, far away from any human settlement near the border between the United States and Russia. Both cases were so isolated, and yet the reach of humans was so strongly felt. That is the other reason why we are happily spending our Thanksgiving doing research, conservation. Last summer, I was on a whale watching cruise organized by the Aquarium of the Pacific to lure the press into talking with scientists about their new exhibit called Voices in the Sea. We found a lone blue whale lounging about, giving everybody beautiful views of its cerulean blue body slipping beneath the surface. Its huge flat head made the water bulge up and then cascade off just as it spouted 20 feet into the air. Everyone was thrilled and cheered and clapped at the beauty of it. In the background was some of the old pilings that are all that remain of San Pedro Whaling Station. Thousands of blue whales were turned into dog food at that station. What a sea change, from a moral standard that appreciated blue whales only as a cheap source of protein to one that glorified their natural wonder. Our past excesses led to laws to protect these wonders, and our research allows those laws to be effective. We provide this scientific data that allows achieving a balance between human exploitation of the sea and human love of the sea. Today would be considered to be foul weather by most. We are beating into mountains of water, and as the colorful New Zealanders say, it's blowing 10,000 a-holes. Only a single mammal observer keeps watch by eye on such a day because holding the huge binocular steady is impossible. But you can still see the big blows. We spend about an hour in the company of two fin whales, second only in size to the blue whales and also never seen before in these waters. The pair was surfing in the rollers alongside the ship. We joined them for a while, going downwind, and they cruised around the boat. We trail a long cable off the fantail that allows us to hear dolphins and whales and learn their position. One fin whale surfed across our wake and for a moment carried the acoustic array on its back. Within my lifetime, both these species were nearly extinguished, and we now gather the data to say whether they have recovered and no longer require special protections. Another species we have focused on here, however, is just going under the protection of the Endangered Species Act. Hawaiian false killer whales have the misfortune of liking exactly the same fish we do. So they not only compete with us for food, but they get tangled in long lines that are set for the fish. We are gathering data as quickly as we can using all our conservation tools: surveys, satellite tags, acoustics, and genetics. We are thankful that we live in a time when some small part of our wealth can be set aside to make sure that other beings will not be irreparably harmed by our actions, and that others can enjoy their magic for generations to come. So that's what I write to my mom. I'm actually going to continue on, oddly enough, at a Southern California venue, talking about Hawaiian false killer whales, because I think they're such an excellent example of how to think strategically in doing conservation science. And the take-home messages are that collaborations are essential, that piggybacking should just become a way of life for conservation scientists, and that new technologies are very timely and we should use them at every opportunity. And finally, uncertainty. We can deal with it, and I think this is a really interesting example of how, even though there's lots of uncertainty, we can make some very certain decisions. Most of what you'll see today, both the work and the slides, are courtesy of this intrepid Cascadia crew. You have Robin Baird, Daniel Webster, and Greg Shore. I had the pleasure of going out with them for a week a year ago, and we left the dock at 6 o'clock in the morning. We stood on our feet all day. Lunch was a sandwich in one hand and binoculars in the other hand. But fortunately, when we hit the dock, I would get a call from my mom, who would insist that I go out and drink Mai Tais and go to luau's. So I missed all of the data curation and equipment preparation that kept these guys up late at night. And we did a little bit of everything during that week, and I think it was not an atypical week. We picked up a harp, we did photo ID of every cetacean that we came across, we photographed birds, we picked up squid and sent it off to have the species identified, and we even did a little bit of poop scooping. So we made good use of our time out there on the water. And without this research, we would know far, far less about Hawaiian false killer whales. And in fact, we probably would not have seen a petition to list Hawaiian false killer whales. But I think it's really interesting to notice that in the 10 years of this study, the first dedicated funding for Hawaiian false killer whales didn't come until year 4. And in fact, you can see that the beaked whales are sort of the most constant reason for being out there doing surveys on the Hawaiian waters. And like most of our studies, you still have time, aside from the time that you're working on your dedicated questions, to gather lots of other data. And so I'm suggesting that that should be a strategy that everybody does, that we all piggyback. And I think that we're pretty conscientious about that. And I'm not suggesting that Robin Baird change his name to Robin Hood and rob from the rich to pay for the poor, but rather that we can do piggybacking and multitasking, and it's always a win-win situation. This is a list of the collaborators and funders, and you can see they are very many. And the objects of study are in the background. I don't know how well you can see that, but the lead false killer whale there has a mahi sticking out of its mouth. And they have a really fascinating ritual of taking the fish and passing it between the members of the group before they decide to take the first bite and chew up the fish. And I think there's a couple of lessons that we can take from our false killer whale friends. One is that if you're working in a very thin soup and looking for a little tiny piece of meat, you're always going to do better working as a team, and that you may perish if you try to do it alone. And so there's a real advantage to working in a group, to pulling in all of these resources and people when it comes to tackling these difficult problems. The other thing is, of course, that they're doing a level of data sharing I think that we couldn't possibly imagine doing. And it also allowed to see how those individuals interact with one another, and also how they interact with fisheries by looking at the scarring patterns. Here you can see a social network diagram. The red dots here are what we now call Hawaiian insular false killer whales, and the little lines that go between them indicate that those animals were seen together sometime between the 1986 beginning and 2009, I think this diagram goes up to. These animals were seen further offshore and do not link in with these animals. And these animals in blue were seen off of Hawaii, and they were seen in habitat that is the same habitat utilized by these whales, but they've never been linked to them. I'll come back to this group of animals in a minute. As you noticed, most of the effort was in the lee of the island, so to really understand and get an idea of how these animals utilize their habitat, they were able to use satellite telemetry. And here you see all of the hits, and you can see that basically these are home bodies. Most false killer whales are seen far, far out at sea. It's one of the reasons that we know so little about them. And here's an offshore animal here. But these animals obviously have found some way to make a living quite close to land, and really for a false killer whale have a very small home range. The genetic side of the picture bears out that they're not only distinct, but they're quite special. And what you're looking at here is a network of mitochondrial DNA haplotypes. You can think of them as being like last names, and you can see that the 80 individuals that we had sampled from the Hawaiian Insular Group had one of two names, and those names are not found anywhere else. And this covers a very broad swath of the ocean from the eastern tropical Pacific all the way to the Indian Ocean in these animals that are sampled out here. The animals that are found just offshore have a variety of names that are sprinkled around in this part of the network. So they look like they're quite different whales. We get a similar pattern in the nuclear data, but it's a little bit harder to visualize. There was also some unsettling data about the status of these whales. Randy Reeves and Steve Leonardwood did a flight in 1989, just a few days of flights off the western side of the Big Island, and they were trying to see whether there were enough false killer whales to remove some individuals for captive display. And so they wanted to get a minimum count. So they went up, as I say, just for a few days, and they counted 470. So that should indicate that there might be something going wrong there. Furthermore, we have this set of surveys, aerial surveys, that was done by Joe Mobley and crew. I don't know how well you can see those lines, but basically their surveys over a period of years covered almost exactly that area that you saw all the dots from the satellite telemetry. And they looked at the number of groups per 10 survey hours, and you can see this starting in 1993 and declining down to no detections by about the year 2000. And to check to make sure that that wasn't just an artifact of the survey, we looked at other species and found that the other species were not increasing or decreasing significantly. So this looks like a real decline. The cause or causes of decline remain unknown, but there certainly are some suspicious players in here. You can see the list of things that the false killer whales have been observed to be eating off the Hawaiian Islands. Looks very much like a menu at a restaurant in Hawaii. They like the same things that we do, good tasting fish. And there are no depredators, which means they're trying to steal fish off of the lines. And as a result, there are known mortalities, becoming entangled in the lines. There's certainly ingested hooks, and fishermen in the past at least have been known to shoot at the whales to try to save their catch. And certainly there's going to be some competition for the fish that are in these nice, relatively lightly sprinkled Hawaiian islands. There's just not that many fish out there. So about a year and a half ago, the NRDC petitioned to have the Hawaiian Insular False Killer Whales listed under the Endangered Species Act. And what happens at that point is the agency has to very rapidly make a decision as to whether that petition is warranted or not. And once they decide that it's warranted, a clock starts ticking and you have 12 months to make a decision about whether or not it should be listed as endangered, threatened, or not warranted. And it's become very common to convene a team of agency scientists to review the status of stocks to help make this decision. So I was a member of this biological review team, it's called, and we put out this report, and it's available online. And I'm just going to touch on a few light points, but it's a very nice review of all of the data, and also we tried to make as clear as possible how we use the data to make conservation decisions and decide the status of this stock. So I'm just going to use a really simple example of how we try to deal with uncertainty and make this process as transparent as possible. Usually what happens in these cases is we try to estimate the risk of extinction, and that often involves doing a model that's relatively complicated, and of course there's uncertainties in all the way that you make the model and the things that go into the model. Usually that's left up to the modeler, and having been one of those modelers, I can tell you it's a pretty uncomfortable process to be making all of this long list of arbitrary decisions. In this case, we basically did it as a team effort. We looked at every single element that went into that model and decided how to do it and recorded how we made that decision. So let's take the simple case of whether or not we include these Hawaii whales in amongst the false insular killer whales. It does that, if we included them, it does two things. It increases the abundance, but because these guys were seen relatively recently and weren't seen previous to that, it also has an effect on the trends. So it potentially has quite a large effect. So what we did was we sort of combined the League of Women Voters methodology with a process that's called structured decision making. So we broke down the problem into lots of simple components, and then we tried to outline arguments for and against these different components, different routes that you could take. In this case, we were looking at should we use or not use these Hawaii whales in the market capture estimates. So we wrote up the arguments for and against doing that as completely as we possibly could. And then we gave each member of the team, which are called here voters A through H, 10 points. And everybody voted independently. We went back in our laptops in our hotel room and we had a whole list of questions and we voted on these things. And then we came back into a room and we looked to see whether there were any really large discrepancies. And if there were large discrepancies, then we discussed those, just to make sure that we all understood the arguments clearly and that we hadn't missed any arguments. And so what we were seeing was really a reflection of how people, what their beliefs were, and not some linguistic uncertainty. If there were some changes, we made those changes in our description of the problem and re-voted again. So we did this many tens of times, actually, to put this all together. And you can see here that there's still a whole lot of uncertainty. And the way that we dealt with this is now we're going to go through and we're going to have a whole bunch of different risk models. There's going to be some models that have those Hawaii whales in there, and some models that don't have the Hawaii whales in there. And when we look at those, we're going to weight them relatively equally, because either one could be the case. Well, this is what the most likely set of models produce. And what you're seeing here is population size and time along this axis. So in 2000, the most likely value was about 1,000 individuals, and it's declining down to almost certain extinction by 2050, which is pretty grim. So even though we had all this uncertainty, we ran 45 different models, we basically came up with more or less the same answer from a big picture perspective. We did the same thing when we looked at the risk factors. We have a very complicated and much longer list that's in the report, and it shows actually all of the voting process in detail, but this is just a summary of that. And I think it was a really useful process, and I think we shouldn't wait until something's petitioned to be listed as endangered before we take on a process like this, because it's very revealing. Some things come out very clearly out of a process, and some data gaps are identified. It's a really nice process, I think, to do on a regular basis. And I'm not suggesting that these actually are going to tell you the order that you need to do research or the order that you need to take action, but you can cross some things right off your list. And you can save a lot of finger pointing if, in fact, everyone agreed that vessel strikes for Hawaiian insular false killer whales were just not an issue. So don't worry about that one. So we went ahead and had to come up with some way to define risk and how risky things actually were. So we defined near extinction as fewer than 20 individuals, which is about the average group size. And the group felt that the average group size was there because that's how these animals managed to find prey in a pretty prey-free environment. And that once you got below their average group size, things would start to go to hell in a handbasket. So it was a pretty easy choice for what near extinction would be. Then we went ahead and defined high risk, defined as a greater than 5% chance of reaching near extinction in 75 years or 3 generations. Then as a group, we discussed whether or not we could make conclusions looking at those 45 models. And despite all those uncertainties that I mentioned, the team concluded by consensus that Hawaiian insular false killer whales have a high risk of extinction. So despite all of this uncertainty, we were quite certain that they were at high risk of extinction. And it's a very important lesson to learn. So the overall lessons we can take home from this whole exercise is that we need to piggyback to do as much as we can with as many species as we can, regardless of the question and funding source. That we need to collaborate. In this particular case, I think that endangered ruling would not have come out unless it had all of those multiple lines of evidence. It had the satellite tagging, it had the genetics data, it had the abundance data, and all of those had to come together to have this clear-cut case. We need to use every method possible. Of course, it's really important to use the new technologies, but in this case, the old technologies were every bit as important. The other thing that I think is really an important lesson, even to me, and I've worked on a lot of these, is that you need to pop the question before it's too late. I was really going into this thinking, well, maybe we don't have enough data, that we aren't going to be able to say we'll spend a lot of time and resources. And in fact, it was a very clear-cut case once we sat down at the table and started putting all of this together. So we can deal with these uncertainties in a really transparent manner. And of course, the last thing is that we need to prioritize our threats. So a classic case where that was not done is 5G. That was a very hard lesson. And, years before they actually went extinct, conservation scientists sat down and they gave a very depressing laundry list of everything that was going south for 5G. And it was a long laundry list. And I'm not saying that it isn't important that they were horribly contaminated or that they were getting hit by ships. But if you didn't deal with getting entangled in rolling hooks first, you were going to lose them. And that's exactly what happened. Which brings me to my second example. I'm going to talk about where we are right now with Wakita. And I think we've actually done quite a good job with Wakita at narrowing and saying the problem is gill nets. So I'm not going to talk about that. But now we're in this odd situation where we have a group of people, including the head of the Mexican recovery team, who think the problem is solved, and we have a group of people who know that the buyout scheme didn't work, that think the problem can never be solved. And they're both wrong. And I think it's really important for us as conservation scientists to get that message out there and to say it as clearly as we possibly can. There's a paper that is either up on the web or almost up on the web that is by Tim Gerardet and Lorenzo Rojas Bracho that asks the question of, is the problem solved? And it's will be up in Marine Mammal Science. And what they did was they looked at the current reserve refuge, which is this polygon in the middle here, and they compared it to several different options, and they asked, are the vaquita going to be able to recover? I don't know if you can see, but there's a bunch of little faint circles in here that are actually vaquita detections. And if you just look at this diagram, you'd think most of the vaquita are inside here, and they might actually do okay. But it's a little bit misleading because there are some little circles that are out in this area. And it turns out that the big ship did the surveying here. They have the highest probability of detecting the vaquita, and they can't go into the shallow water areas. We actually surveyed the shallow water areas using a sailboat and a towed acoustic array and funding from Pacific Life Foundation. Thanks for that. And it turns out that about 40% of the estimated 250 vaquita are in that shallow water area where the big ship could go, which is a very important thing to know, especially because that's where all the fishing effort is now. So all the fishing effort has been pushed from that refuge out into the shallow water areas. So that's what they're trying to do here, is assess, is that fishing effort that's out in that area where the vaquita are unprotected still going to be driving the population down. So what we're seeing here is the number of vaquita that are killed, estimated to be killed each year, starting with about 60 animals per year in the early 1990s. This decline is because the number of vaquita are declining. There's simply fewer vaquita to be killed. But this drop is the result of that refuge, which is something that we have to remember. It's a very important feature. And the question is, now can they support the continuing level of mortality? Here you can actually see the estimate of abundance declining over this period, which was a very grim period indeed, up through 2008. And here you see, I might point out on a different scale, so this is about a little over 200 animals here, 2008 projected forward, and this line is with the refuge. So you can see that the population continues to decline, but it continues to decline quite slowly. So it's bought us some time. It's not solved, so it's very clear that we can say the problem is not solved. But it's also very clear that we've got some time to still come up with some solutions for vaquita. As probably you know, things are pretty grim south of the border here. There's a full-on drug war that's going on right in the zone where vaquita are. There's really a lot of economic hardship. And right now, conservation is taking a lower priority for the government of Mexico. And I don't think we can expect them to have any different attitude than what they're already doing. But I think we can still do some things to help vaquita weather this period in Mexico. So one of the things that we did in 2008 was we tested out different methods to be able to detect vaquita acoustically. And one of the winner device was this C-pod, which you can put out for months at a time, and it detects the presence or absence of vaquita. So we brought together a team of scientists, and we asked the question that the Mexican government asked of us: what would it take to be able to detect a 4% per year increase in vaquita in a 5-year window? They wanted to be able to come back and say, yes, it's worth all of this paying fishermen to not utilize this area because vaquita are actually recovering. So the team got together and we figured out that it would take 5,000 C-pod days.
And what you see here is the grid that we designed that would give you 5,000 seed pod days. It's 63 of these devices. They would have to be in the water 100 days a year. And we accounted for about a 20% loss rate. And our Mexican colleagues are just wrapping up the pilot study. And we hope to go down there in March and take a look at the new data, which is much more data than we had when we came up with this design. And then hopefully be able to implement a full monitoring program by maybe starting as soon as this summer. The reason that this is important is that we really need to keep these species in the spotlight. They're hard cases. It's going to take a long time to solve them. It's hard to keep your eye on the ball, and that's exactly what didn't happen with YG, and what we don't want to have happen with PETA. At the same time, we need to do some other things to come up with some ways so that we can reverse that decline. So we're doing pretty well on number one here, keeping the problem in the spotlight. We need to continue to support the local scientists in their efforts and educate others at every opportunity in Voila. We're doing just that. Very importantly, we need them to be the ones that maintain optimism here. If we are pessimistic about the odds of these animals making it, it's going to make things a lot worse for Makita. The refuge has bought us some time. It's true that economic times are rough and that the drug war makes conservation a lower priority. But the international community now has the time and needs to step up and develop alternative fishing methods, because that's clearly the only way that the Makita are going to be saved in the long run. Another important strategy for doing conservation is that while we have these tough, long-term cases like Makita, we need to also be telling people that the Endangered Species Act has made a difference, that these tough conservation laws really do have a good effect. And we've got several large whales that I think are ready to come off the endangered species list, and I think it's an important thing for us to move that forward. But there are some niggling details, and I'll cover one of those. Fin whales were listed in 1972 when Richard Nixon was president. And they were listed globally, which was appropriate because they were being unsustainably whaled over most of their range in 1972. They could have been listed by subspecies at the time, but they weren't. And even if we went to that level now, we'd have problems because we have a lot of taxonomic uncertainty about fin whales. The animal that you see at the top of the panel is a photograph from Maine. Their catalog uses that white blaze sort of back of the blowhole there. And the animal on the lower panel is in Pacific, where we use the dorsal fin instead, because the blaze doesn't allow us to individually identify animals. They're quite a bit darker. And this is almost certainly due to the fact that they're probably different subspecies. So fin whale distribution is driven by their lack of nice, warm, toasty tropical waters, and also not going into really heavy ice. So they're isolated into these three ocean basins, the North Pacific, the North Atlantic, and the Southern Hemisphere. Many years ago, the animals in the Southern Hemisphere were described as a separate subspecies, Balaena physalis folii. And what happens in the taxonomic rulebook is that everybody else becomes the nominate subspecies, Balaena physalis physalis. But in fact, there's never been a comparison between the North Atlantic and the North Pacific. And we're just starting to do that now. And we've been approaching the problem of looking at how good this current subspecies of cetaceans are. And they are all the subspecies that are out there were based on morphology. And sadly, the group that looked at whether these guys would meet the muster of today's data standards concluded that the basis for splitting this subspecies was not a good one. It was based on like two skulls that were bigger than the free skulls from up here. So it wouldn't be something that we would accept in a scientific publication today. So we're doing a study with fin whales that's very much like what Phil Moran discussed this morning, for those of you who were able to see it, on killer whales, where we're looking, using all of our genetic tools to be able to look at the taxonomic status of fin whales. And I think a year from today, I could be standing up here and telling you what the status of these 3 units are. So I think we can make progress in taxonomy quite quickly. The bird people, some people call them ornithologists, the bird people have been very active in describing subspecies of birds, and they came up with 4 important features for subspecies. First of all, they're not reproductively isolated, otherwise they could be full species. Their defining features have a genetic or developmental basis. They have a unique breeding range, separate from other species, subspecies, and they're diagnosably distinct from other subspecies. So I started to take just a broad brush look by going through all the distribution map for the 87 species of cetaceans that we have, or that we currently accept. And I found that there were some really interesting things that came out of that. First of all, 67 of those species have no subspecies. And this is despite most of them having discrete distributions, just like the one that you saw for fin whales. So if they were birds, they'd be subspecies. But we don't have skull collections, we don't have the morphological data, so they've never been named for cetaceans. The other thing that was sort of a surprise to me is that reading through the descriptions, I couldn't tell where the breeding ranges were for most of the species of cetaceans. 47 species or subspecies have, as far as I can tell, an unknown breeding range. But you do have the distribution maps that have both the breeding and the feeding ranges. So I just used those to just go through and see how many of them, even at that scale, which overestimates the level of overlap, even at that scale, how many subspecies or species there might be out there, just to get some idea of how much our taxonomic uncertainty is influencing our picture of cetaceans. And it was pretty shocking. I found that there were 43 cases where there was a high probability of more than the currently named subspecies or species, 38 with a medium, and 23 with a lower probability. And I have no doubt whatsoever that some of these will turn out to be full species. Probably many of them will turn out to be full species. So it really hadn't hit me how much we're underestimating biodiversity in cetaceans, because we are so far behind because of the inability to have museum collections of skulls. But now we've got these genetic tools, and I think we can make some progress relatively quickly. We just got a thumbs up from the editor of Marine Mammal Science to put out a special issue that's focusing on subspecies and how to use genetic data in cetaceans to be able to say what are species and what are subspecies. So we're hoping to get some guidelines out there so that we can actually start making some much more rapid progress in being able to reduce this taxonomic uncertainty. Well, why is it important to conserve, to conservation, to know what the units to conserve are? Well, there's the standard scientific reasons, which are important, that understanding risk depends on getting the scale right. And it's entirely possible, if not probable, that species or subspecies that haven't even been delineated could be amongst those at highest risk. And I'm thinking here of coastal and island populations in the tropics. I think there are probably a number of places that we could just look at the map and say, well, that's a suspicious spot. We should look and see if there's something there. But I think there's something that we often forget as conservation scientists, and that is that there's a number of really good news things about having more species and subspecies. One of them I already mentioned is that it will allow us to move forward and take some of these species off of the Endangered Species Act, to recognize where good progress has been made because of strong conservation laws. The other thing, though, is that we need to be able to infect people with how exciting it is to discover new species. And the article that came out in July that Phil discussed this morning that announced new species of killer whales got a huge amount of press. And I think most people are very excited about the discovery. I mean, new species of killer whales on the planet Earth. Wow, how cool is that? I mean, that is just a really cool thing to know. So, and people are excited about that. And it makes, it builds enthusiasm for conservation. It's very important. So I'm going to conclude with 3 points here. First of all, we really do need to combat negativity. There are plenty of people who listen to way too much Glenn Beck out there. And, they don't really want to hear us whining as well. And most people really yearn for some beauty in their lives. And most of us went into doing what we do because we appreciate the beauty and wonder of the natural world. And we need to be able to bring that back to other people so that they can appreciate that and will value the same things that we value. As I mentioned, we also need to really prioritize and break problems down into nice little chewable bits. And I think we can start by really listing out the threats and trying to get a magnitude of these threats and trying to prioritize how we go about doing research. And I think we have some really unique opportunities here in Southern California that we've been talking about at this meeting. And I think there's real exciting promise to make some forward progress in things like understanding and estimating the magnitude of problems with ship strikes, with Navy sonar, with shipping noise, and contaminants. I think all of those things that we're sort of uniquely poised with this group of people and in this place to make some real progress on these. And finally, I'd like to leave you with the very important thing from a strategic point, and that is to remember our role as marine mammal guardians. I think one of the biggest threats to BIG was that the conservation scientists basically looked the other way, and we can't do that. We have to think globally even though we're acting locally. And I think that's a really important thing, that even though many of us will not have the opportunity to work on these species that are at highest risk, there's so much of what we do that can apply to those species, and so much that we can do to help people who are doing the research, that should be certainly one of the focuses that we maintain. Thank you.